a very good evening. Welcome to our Sprint X class number 4 chemistry. In today's class we are going to talk about carbon and its compounds. In fact it is class number 5, but still we are talking about chapter number 4 itself. Yeah. So as you all know the timetable, today carbon and its compounds, the second lecture, and tomorrow we'll be talking about periodic classification of elements, right? And I have seen all your comments in the videos, the previous videos which I have shared with all of you, and most of the students wanted to learn two topics. One is isomerism and the second one is IUPAC nomenclature. So I have covered both of them in today's video, and some of you also spoke about homologous series, and I guess your doubts about homologous series are cleared in yesterday's session itself. But still, in case you want to learn more topics or something, please mention in the comment section of today's video. Done? So come on, let us start the Sprint X class number 5, chapter number 4, carbon and its compounds, right? So there we go with question number 1 on the screen. Let us freeze the screen and read the question. This question has come for 5 marks and it's from isomerism. The year in which this question appeared was 2011. So please observe the question first and then let us discuss about isomerism in detail, okay? Explain isomerism, state any 4 characteristics of isomers and draw the isomers, the structural isomers of butane that are possible. How many ever are possible, those many we have to draw. But then as far as I have understood from your comments that you wanted a clear understanding of entire isomerism, so let us start with that. The concept of isomerism is all about the arrangement of atoms in one molecule of carbon compound. Let me simplify it further. For example, say we are talking about one simple hydrocarbon and I am picking up a hydrocarbon containing 4 carbon units. 1, 2, 3 and 4. You are all aware of the basics of carbon and its compounds, I guess. Every carbon's valency is 4, that's why we call carbon to be tetravalent, isn't it? So now in this 4 carbon chain that we are having, every carbon's valency should be satisfied with hydrogens, correct? So now let me satisfy the valency and I'm writing it as CH3 and CH3 on both the corners, because the tetravalency has to be satisfied with hydrogens only right now, because we are talking about hydrocarbon, not any other functional group containing molecule. What about these 2 carbon atoms? Already there are 2 bonds and they need 2 more bonds, so I have taken 2 hydrogens over here. So what is this molecule? Can you please name this molecule and tell me? Can you please name this molecule? It has 4 carbon atoms. So root word is what? Tetra, right? And what about bonding? All single bonds. So it is hexane. It is ane, not hexane. It is ane, right? So it's having 4 carbon atoms and it is having all single bonds. And root word for tetra or root word for 4 carbon atoms is but plus ane, so it is butane. And now in this butane, you please carefully observe how carbon atoms are arranged. They are arranged in the straight chain, isn't it? And this is the structure of butane, and you count how many carbons are there and how many hydrogens are there. As far as we see, there are 4 carbons, and how many hydrogens are there? 3 plus 3 plus 2 plus 2. Totally 10, right? So there are 10 hydrogens. So what is the molecular formula of this structure of butane that I have written over here? The molecular formula is C4H10. Done. So C4H10 is the molecular formula and IUPAC name is butane. That's over. But then is it necessary that I write butane in the same straight line manner? Can I not rearrange the carbons and hydrogens in this butane same according to the valency concept? Can I not write it in a different way? Just like a puzzle, you know. Try this out. Observe now. 4 carbon atoms. It's not mandatory that they should be in the straight line, isn't it? So what am I doing right now is I'm taking 3 carbons in the straight line and I'm taking the 4th carbon atom. I guess this color is not clearly visible. I'll take red again. And the 4th carbon atom here. Okay, done. So what is happening? It is still 4 carbon containing molecule. but still we have changed the arrangement from straight line to branch. Did you notice that? Yeah. Now satisfy the valency of carbon atoms with hydrogens. Again, it will be CH3. This also will be CH3. Valency satisfied. Every carbon should have 4 bonds, correct? And followed by this carbon. Observe. 1, 2 and 3. Already 3 bonds are there. That means it just needs 1 more hydrogen, correct? What about this carbon which you have here? Satisfying valency with hydrogens. And now again you please count the total number of carbon atoms present here in this entire molecule. Do you find 4 carbons? 1, 2, 3, 4, right? So C4. And now can you also count hydrogens? Are you all doing it? Please follow the instructions so that you understand concept of isomerism clearly. Okay. So there are 3 plus 3 plus 3, 9 and 1, 10. Totally 10 hydrogens are there. C4H10 again, correct? So what is C4H10? Butane. So now tell me, which is the actual structure of butane? Is this or this? The first one or the second one? Both are butane. I did not specify anything, right? Like in butane, the 4 carbons should be in the straight line or whatever. No, it's not mentioned. So one among them could be butane. So these two structures, structure 1 and 2 of butane, are having same molecular formula. Are they? Did you verify? You did, right? They are having same molecular formula, but they have different arrangement of atoms. When you draw the structure, they have different arrangement of atoms. Okay. What do you call this phenomenon as? This phenomenon is called as isomerism. What is isomerism? Isomerism, technically speaking or technically defining, is a phenomenon due to which same compounds will have same formula or molecular formula, chemical formula, but they will have different structural formula. What is structural formula? If this formula is confusing you, cut this. They have different structures. So isomerism is a phenomena in which the molecules having same molecular formula will have different structures, and those different structures are called as isomers. And in the question they asked us to write the isomers of butane. That's what we have written now, but once more you try to draw it in your book without saying. Right now, draw the isomers or structural isomers of butane. How do you do it? C4H10 is a structure, it's given. Take 4 carbon atoms, arrange those 4 carbon atoms in how many ever methods that you can. There will be only 2 methods possible. You try it. Okay. One is when you have arranged all carbon atoms in straight line. Second one is 3 in straight line and 1 adjacent as a substituent. Can you try some other method for butane? Say yes or no. You try. Isomerism is one concept that you will understand only when you try in your books. Is that possible? To make some other arrangement for butane other than what is written over here? You can't. It's not possible. How would you? That's it, isn't it? So now if you're thinking of changing this group to this, there is no big difference. If you're connecting the CH3 group at the end, it's again the 4 carbons attached end to end. It becomes the straight line again, right? So only 2 ways that we can arrange the atoms of butane. So how many isomers are possible for butane? 2 structural isomers are possible for butane. Are we clear? Yeah, I'm quickly summarizing what did I say so far. We are talking about isomerism. What is isomerism? A phenomenon due to which or in which the molecules with same molecular formula will have or will exhibit different structural formula or different structures. It's one same molecular formula being arranged in different ways. Yeah. How many structural isomers are possible for butane? You just have tried. 2 are possible. More than that cannot happen, right? And now moving on to next point. Like, is there any similarity in the properties of these isomers? Like, we are talking about these two isomers of butane. What are their characteristics? Do they have any similarities, dissimilarities? Like, what are their behaviors? There you go. 4 points, very important. Isomers are different in structural formula. They are non-identical structurally. They differ from each other structurally. Point number 2. They differ in melting point. Why? Remember, melting point, boiling point are the properties which depend upon the structure. If the structure of any molecule is changing, melting point and boiling point also will change. And to talk so pinpointedly, melting, boiling point depend upon structure and chemical bonding. Do you remember when you compare covalent bond and ionic bond? Ionic bond has high melting boiling point than covalent bond containing compounds, right? So you're talking about melting points and boiling points here. Because your structure is differing, melting point also differs. Are you all able to follow what's happening? Yeah, great. Next one, they differ in boiling point also. I think we just spoke about it as well. They differ in solubility in the same solvent. Why? You remember what is solubility? Class 9 CBSE, yeah, chapter 1 or 2, correct? Solubility of any material is something which depends upon two things: its type of bonding and its molecular size. The molecules which have ionic bond or polarity will get dissolved very easily. And if the molecular size is going on increasing or the bonding is getting complicated, solubility reduces. So solubility, melting point, boiling point, also stability are the properties which in turn depend upon the structure. Because isomers are having different structural formulae, their melting point, boiling point, and also their solubility, stability are different from each other. Are we all clear about these all points? Are we all clear? And don't worry, we are going to practice more examples on isomerism right now. Maybe in question number 3, not right now. Okay. Did you understand what isomerism is? Yes, right? Okay, so quickly moving on. Isomerism is the phenomenon in which same molecule with a molecular formula will be exhibiting different structural formulae, right? I hope everyone's clear about that. Yeah, and the isomers of butane and pentane are often asked in the exam. So quickly make a note of butane's isomers. I think you already made a note of it. Pentane we'll talk about in a while. Okay, moving on to the next question. Isomerism continued in question number 2 itself, not in question number 3. What are isomers? Why can't we have isomers of first 3 members of alkane series? A 3 marker from 2012. Previous question was from 2011. Did you see, like, consecutive years? What are isomers? Question number 1, we spoke about isomerism, a phenomenon in which I am repeating multiple times. You also repeat along with me and learn the definition perfectly. A phenomenon, isomerism is a phenomenon in which same molecular formula has different structural formulae or have multiple structures, and those multiple structures are called as isomers. Yeah, see, and these isomers, let us go to the answer page. And these isomers, because they have different structures, have different physical properties, like melting point different, boiling point different, solubility different, stability different, right? You remember all of that, right? Now look at this important part of the question. Why can't we have isomers for first 3 members of alkane series? What are the first 3 members of alkane series? I am writing it here. You try to write isomers for them. Okay, first member of alkane series is CH4. How do I know it is first number? Array, C1, right? Can you have an alkane with less than 1 carbon? Not possible, isn't it? Second one is C2H6. Second member, because it has 2 carbon atoms. And what about the third member? Before we could go to the third member, I have a question. Can you please tell me what can I call these 2 together? Like, is there a relation between both of them, and what do you name that relation as? We spoke about it in yesterday's class, and I'm expecting answer from everyone who is watching this video. What is the relation between CH4 and C2H6? Very important one marker in both point of view. Some of you have answered, I guess, and some of you are still thinking, Arey, they are homologous series. They are homologous to each other. What is the difference between them? 1 carbon and 2 hydrogen difference. Did you notice? So they are homologous series. They are homologous to each other, right? Yeah. What are homologous series? The members of the same family which differ from each other with respect to a CH2 group. There you go. And the next member of the same series has to be C3. What about hydrogen count? You count and tell me. There should be CH2 difference. C3H8. Did you also say the same? Then you are rocking. C3H8. So these three are the first 3 members of alkane series. Okay, let's come to this question. They are claiming that why can't you, they're asking us why can't you have isomers for first 3 members of alkane series. You please try the structural formula of these 3 members. Don't look at the answer written over there. You try it and then identify why are you not able to write isomers. I'll also try along with you. I have CH4. Whatever I do, I don't think I can change this arrangement. If you are talking about moving hydrogens, okay, move, but hydrogens are hydrogens, right? So, kya farak padta hai? Right? So, isomers are not possible for first member because it just have 1 carbon. The carbon count is not enough or not sufficient. What about C2H6? C2H6, I'm drawing it here. C2 over H6. 6 hydrogens. Okay, there you go. And here is one, and the remaining hydrogens are here. Please change or please rearrange carbons or hydrogens in this molecule without failing the concept of valency, and tell me the isomers if possible. I am sure by now everybody have got to know that not possible for this also. What do we change here? Not possible. Carbon count is not enough again. What about C3H8? Propane, right? Okay. 1, 2, 3 carbon atoms. So there you go, 3 hydrogens and 3 hydrogens. Okay, this looks a little lengthy, but can you please try if it is possible to get isomers for this molecule? Can you change position of this carbon and this carbon? No difference. Again you will have terminal 2 CH3 groups. What is the difference, right? What about the center carbon? Whatever you do, the molecular formula, structural formula are gonna remain same. Did you get the point? So carbon count is not enough to make those puzzleistic structures over here. It's not possible to have isomers. The reason is written over here in format, but actual reason that you already see here, the number of carbons is not enough. And let's put it in the proper frame because we have to get this 3 marks, right? So well, in the first 3 members of alkane series, branching is not possible. What's branching? Do you remember butane ka case? In the second isomer of butane, one CH3 group was attached to the chain, main chain. I'll represent it here. It was like this, CCC, and 1 carbon was attached. This is called branching, and that can't happen in these 3 molecules. So because branching is not possible, we cannot have isomers. Simply, in simple words, branching is nothing but that rearrangement wala funda. Are we clear? First 3 members of alkanes can't have isomers because branching is not possible. Why branching is not possible? Array, carbons are not sufficient. We just have less number of carbons. That's why. Are we all clear about isomerism? So, to talk more about isomerism, it's not elaborately given in NCERT. But then we still find questions in board. You know, CBSE boards are like that. So please don't stick to only the lines of NCERT. Also learn a few points out of the textbook. How do you know which points that you have to learn? Please practice previous 10 years question papers of chemistry, science altogether. Do you need the PDF form of it? Let me know in the comment section as usual. I'll view your comments and I'll reply to them. Done. So now quickly moving on to next question. You tell me, shall we move on to next question? Shall we practice one more? Yeah, I'll take you to the previous slide. Let's practice one more, not the third one. space is here, that's why. I'll give you a molecule now. You try to write isomers of that. Okay, most of you have asked for isomerism, so I'm taking this up in this video. Make sure you get perfect in isomerism. After this we'll move to again your favorite, ethanol ethanoic acid wala concept. Okay, taking pentane this time, and for your convenience I'm drawing the structural formula of pentane. 1 2 3 4 5 carbons over. So along with me, draw the structure in your book, and also try the number of isomers that you can write for this molecule. Quickly guys, hurry up. How many isomers are possible for pentane? This is pentane. Is this pentane? How do you know? You check. 1 2 3 4 5. Root word is pent, correct? All single bonds, it's A, and I'm waiting for your number of isomers wala answer. Just tell me the number 1 2 3 4, how many ever that you find. How many isomers are possible for pentane? Done? If you have done so quickly, that means you are rocking your revision, and those who are still doing, I'm also giving you some hints. Okay, done? One isomer I already have written. This is the actual formula. Now just to simplify the stuff, this elaborated structural formula, I'm just writing it in simple manner. CH3 CH2 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 CH3, the same thing. Did you notice? And just to keep the thing simple. Okay, in exam you can choose to write this or this, your choice, and you will get full marks even when you choose one among them. Done? Now this is one isomer. Done. The second arrangement. Now what do I do is I'll take 4 carbons, 1 2 3 4, and the other carbon as a branch. Okay, branch where? Can I take it on the last carbon itself? Then what is the change? Anyways, in the previous molecule, last carbon itself is attached to this one, right? So attach it to this carbon. Then balance the valency. Did you get the same thing? The ones who have tried it, did you get the same thing? Is this the isomer? You have to check and tell me. Is this the isomer? It is, right? How do you know? Carbon count and hydrogen count. This is pentane. What pentane? Okay, this is pentane, but is there any specific name? Yeah, you can also name isomers. How? We'll try that in learning IUPAC name in some time. Okay, done. Next one. Next one, in spite of taking 4 carbons in the same line, I'll just take 3 carbons in the line. Are you all following? Practice it along with me in your book. 3 carbons, okay, and the remaining 2 carbons here. That's possible, right? What is the valency of carbon? Carbon's valency is 4, so central carbon with 4 bonds, it's cool, right? CH3, CH3, CH3 and CH3. Can you please check if all these 3 structures are having same molecular formula or not? Check it now, right now. So 5 carbons, okay, C5, and how many hydrogens? 3 plus 3, 6, plus 2, 2, 2, 6. 6 plus 6 is how much? 12. So it is C5H12, right? Done. In this, not the green one, the red one. Did you get the same formula? Are you sure? And in the third one, yeah, same molecular formula, 3 different arrangements. So you call it as isomerism, you call the phenomenon as isomerism, and you call these structures as isomers, right? Are we all done with isomerism? No more questions? If in case you are having any doubts about isomerism, feel free to put it in the comment section. I'll help you out, okay? Moving on to question number 3. There you go. So in question number 3, they are talking about list in a tabular form 3 physical and chemical properties on the basis of which ethanol and ethanoic acid can be differentiated. I did not write the year in which it's been asked over here, but then this is one of the very important questions in your syllabus. I told you yesterday also, right? From entire carbon-rich compounds, there are few some topics from which you can expect questions for sure, like soaps and detergents. Next one is this. So there you go. I have picked up the tabular form for the differences. I hope this helps you. So now what shall we do is, yeah, let's talk about the physical properties to begin with, okay? Physical properties are the ones which can be perceived with the help of physical senses. So look for smell, odor, or maybe texture, taste, physical state, and all of that. Okay. Ethanol, ethanoic acid. Before we could get into that, the formula. Can I see the formula of ethanol, please? Ethanol formula. Yeah. I hope everyone's actively participating. Everyone who's watching this video, let your brain act. Even if you don't write the answers in the chat box, it's okay. Let your brain be functional. Yeah. So we're talking about ethanol first. Ethanol is C2H5OH, right? And the second one is what? Ethanoic acid. Ethanoic acid is CH3COOH, correct? So now, before getting into this, I would love to ask you one question based on what I have taught you yesterday. Can you tell me the functional group in ethanol? Silly question. Ethanol, I'm telling you the name and asking you for functional group. OL, all. Alcohol this is. Ethanol is an alcohol. It has alcohol functional group. What about ethanoic acid? Functional group. Oic acid is nothing but carboxylic acid. Right? So first thing, be clear about what is the functional group, and second thing, be also clear about their nature, like are they acids or bases or what are they exactly. Carboxylic acid name itself is suggesting, so it's an acid. Alcohol is a very weak acid whose pH lies around 6.8, very close to neutrality. So it doesn't give you any indicator test and all of that. It behaves almost like neutral. Okay. Almost like neutral. Coming to behavior, looking at pH, 6.8 is the pH. Okay, done. Keep these two things in mind. Based on the same, we'll talk about chemical properties. Let's talk about physical properties now. Both are liquids at room temperature. Moreover, both are no specific color and all that. It has specific smell. What? Ethanol. Have you ever gone to a hospital? You must have. The spirit smell that we have in hospital resembles the smell of ethanol, and followed by ethanoic acid is present in vinegar, so it smells like vinegar, and I'm sure everyone in house has vinegar. We use it for preservation, cleaning, and all of that, right? Followed by, if you can taste alcohol, it has burning sensation on your tongue. And acids are sour. Carboxylic acid is acid by nature, so it has sour taste, right? Try to relate the properties, then your job becomes easy. I always tell you this, relate and learn, don't by heart. Third point, it does not freeze in winters. Acetic acid or ethanoic acid freezes in winters. Important point, and less aware we are about this, right? Next one. What about the chemical properties then? Is there any chemical property wise difference? Yes, there is. But before we could get into chemical properties wala difference, I would love to ask you, are you all making note of the important points? You are, right? And are you all learning along with me? I mean, are you all learning through this video? Yeah? Say it along with me when I repeat the definitions. Yeah? Done. Right, moving on to chemical properties. Alcohol is neutral. So you tell me, can a neutral substance react with a base and undergo neutralization? Sounds weird. It does not. Neutralization happens between acid and base. You all know it, right? So when you take a base like sodium bicarbonate and put it into ethanol, nothing happens. They remain as they are. No change. So it does not react. Why? Alcohol is neutral, so you can't expect alcohol to react with a base and give you neutralization and all of that. But what about ethanoic acid? It's acid. It would love to react with base or basic substances. So when you add a pinch of NaHCO3 into vinegar, you can see that fizz of carbon dioxide coming out. It immediately reacts and also releases carbon dioxide. What do you see when ethanoic acid is added to sodium bicarbonate? I get to see the fizz of carbon dioxide because they react with each other. Observations of reactions are important. Next one, ethanol is a fuel. It burns with a blue flame. Ethanol is used as a spirit in spirit lamps in the laboratories also. It burns with silent blue flame. Moving on to ethanoic acid, it's covering over here, but then it does not burn with blue flame. You must have seen the things disappeared from the board, but I think you already have noted them down, right? So it does not react or it does not burn with blue flame at all. Third, difference between both of them. I guess it's here. Yeah, third difference between both of them is it does not affect blue litmus. Do you know why? What is the effect of neutral substances on blue litmus? Will the blue litmus turn red at least? And if you apply the same concept over here in case of acid, it happens. Why? Blue litmus turns red only in presence of acid, and ethanol is neutral by nature, so no effect. And ethanoic acid, because it is acid, will be having an impact on blue litmus. I hope you're all clear about the differences. Yeah, and now let me also write the equation for point number 1. Okay, reaction between ethanoic acid and NaCO3. So when you take ethanoic acid, CH3COOH is the formula, plus NaHCO3. Now I would love to wait for your answers, because you are all now proficient in identifying the products of the reactions. You are, right? You have watched video number 1, 2, 3 of Sprint X chemistry, right? We discussed about how to write the products. Identify how many cations and how many anions do you have here. From there, interexchange and write the products and tell me. I'm just helping those who are stuck. Okay, here is one type of cation, here is another type of cation, one type of anion and another type of anion. So 2 cations, 2 anions lead to double displacement. So what do you do here? Exchange the places. Very simple, right? So what is that exchanging of places? CH3COONA. Next one is supposed to be H2CO3, but then listen to something. H2CO3 or carbonic acid is not stable at room temperature, so it immediately dissociates into what? Into H2O and CO2. So your products are these. Are you clear about this point? So whenever you have H2CO3 produced, you got to write it as water and carbon dioxide. Done. Are we all clear? Ethanol, ethanoic acid, very important question. This is very important question, and often asked part is this: chemical differences. How do you differentiate ethanol and ethanoic acid chemically, right? With the help of some chemical test and all of that. Shall we move on to the next one? Are you all done? Okay, sounds good. So now moving on to question number 5. But before we would go to question number 5, just here, take a look at this. There is one more question which talks about detergents. So it's a 5 marker basically, and many of you have had many questions about soaps, detergents and all of that. I already mentioned in my previous classes that micelle formation is extremely important, and along with micelle formation, these are the points that you have to cover about it. Look at the question. What are detergents chemically? It's a 1 marker independently, and it also could be a part of 3 marker or 5 marker like this. Second part of the question, list 2 merits and demerits of using detergents. There is also one marker possible, like list any 2 disadvantages of detergents, followed by state the reason for suitability of detergents for washing even in case of water having calcium and magnesium ions. I have a question before we could get into the answer. What do you call the water which is consisting of calcium and magnesium ions? Is there any specific name for such water? Yeah, then what is the name? What do you call that water as? Hard water. Yeah, so detergents can be used even in presence of hard water. What is the reason behind it? Done. There are different parts for this question. Whenever you deal with 5 markers or 3 markers, 2 markers, whatever, make sure you point wise answer the questions. You know, that improvises your presentation and increases your chances of acquiring maximum. Done. To start with first one, detergents are chemically sodium or potassium salts of sulfonic acid, or you can also call it as benzene sulfonic acid. Okay, detergents are chemically the salts of sodium, potassium along with benzene sulfonic acid. What are the merits or advantages of detergents? 1, even in hard water chal jayega. What happens if you use soaps in hard water? Soaps in presence of hard water form a lot of scum or precipitate, because soap molecules get attacked by the salts present in water, right? So soaps are less efficient in presence of hard water due to formation of scum or precipitate. But that problem doesn't happen in case of detergents, followed by they are more effective than soaps. Why? Because they can be washed away with less quantity of water also, right? These are the two very important merits. And what are the demerits? They were expensive, but these days there's a revolution in the detergents. You must have seen those all advertisements, right? Surf Excel Matic, Ariel Matic, Daag bhi acha hai, and all of that. So the prices now are more economical, but still they are relatively more expensive than soaps. Okay, but there is one other major and important drawback than being this cost effective and being not cost effective, and that is they are the ones which have branching in the hydrocarbon chain. What hydrocarbon chain? Taking you back to the structure of the soap molecule, a head and the tail, right? And this tail is called as hydrophobic by nature, right? It has hydrophobic behavior, and that hydrophobic behavior is acquired because it is hydrocarbon. So this tail is a hydrocarbon, right? So now in case of soaps, these hydrocarbons chains are simple, but in case of detergents they are complex, branched. So more is the branching in hydrocarbon chain, what happens is the non-biodegradability factor increases. So the detergents or the hydrocarbons present in detergents are usually non-biodegradable, which affects environment, right? That is one big drawback. But then we have solution for it now these days in 2018 and all of that, but still, therefore they create water pollution. Detergents are suitable for hard water. Next part, they are suitable for hard water which is having Mg+2 and Ca+2 ions also, because they don't form that insoluble salt. What is the technical name for insoluble salt? Insoluble salts are precipitates. So detergents do not form precipitate, do not form scum, so they are very useful. I'm just summarizing what we spoke about soaps and detergents. Detergents also have the same structure, but their hydrocarbon chain is complex, so they are non-biodegradable usually. But now we are improvising on the biodegradability also. But anyways, they are non-biodegradable. That's one drawback. Other one is they are not cost effective. They are usually expensive than soaps. Merits: they don't form scum, precipitate, so that you can use them in hard water. And they are more efficient. They use relatively lesser water when you compare with the soaps. And what are they by nature, like by composition? They are the salts of sodium or potassium with benzene sulfonic acid or sulfonic acid of benzene. You getting it right? Same thing written in two ways. Next, why are detergents considered to be more effective? Because they don't form scum in presence of hard water. So the people who are in the villages, in the lower towns also, those who make use of the groundwater sources from wells and bore and all of that, even they can use detergents effectively, right? That's why. Are we clear? Well guys, that's all for today, and by this we have covered all those important points from carbon and its compounds, which are also suggested by most of the students in the comment section of the previous videos. So I hope you practice these all things and also practice more questions based on the same concepts, so that it will be of really great help to your preparation. Done. But in case you have more questions or anything that you want to know about this chapter, or maybe what do you want to learn in next chapter, that is periodic classification, please make sure you put it in the comment section so that I review your comments and I also take up the important topics and help you out. Done. So shall we sign off for today? Bye everybody. Keep preparing, work very hard so that we don't regret later after your result is out. Done. Bye all of you. See you all tomorrow in the next class.